All right. Convert each equation from polar to rectangular. Same formulas that we've been using, okay? Tangent, if you remember, and I'm just going to draw a quick, this is x, this is y, this is r. So sine, cosine, tangent, secant, cosecant, and cotangent, you can quickly get your x, y's, and r's right off that triangle, okay? So tangent is y over x. And then anytime we have an equation, we want it to be in standard form, whatever that equation is. So in this case, I'm going to multiply by x, and I have y equals 2x, okay? Next, r equals -4 secant of theta plus 30. This is a cosine of a sum. Again, use your identity sheet if you need to. So I have cosine, cosine, sine, sine, sine. Some of these are going to get rugged with the fractions and things like that. I have r equals -4 over cosine of 30. And again, if you're not familiar with these, draw a 30, 60, 90 triangle. So I have 30, this is 1, 2, square root of 3. So cosine of 30 is square root of 3 over 2. Okay. Sine of theta. Sine of 30 is 1/2. I'm going to multiply this side by 2 over 2 to clear those 2's. And then cosine is equal to x over r. Sine is equal to y over r. And then, and actually I forgot to multiply the top by 2. There we go. And then I'm going to multiply both sides by r. Actually, I'll multiply this side, I think, by r over r is what I'll do first. And then I'm going to run out of room here. I have -8r over x squared to 3 minus y. And we'll just do this. I'll keep going on this paper here. Notice I have an r on top on both sides. So I can divide both sides by r or multiply both sides by 1 over r. Okay? And then this is in the denominator, so I'm going to multiply by this. So if I multiply both sides by x squared to 3 minus y, and then divide both sides by r, I'm going to have x squared to 3 minus y equals a -8. So it's kind of ugly, but it's actually a linear. Okay? And want to solve for y. So fastest way, I'm going to add y and add 8. So I have x squared to 3 plus 8 equals y. So this would be a linear with a slope of the square root of 3 over 1 and a y-intercept of 8. Okay? All right. More, because we have linears. Now we're going to have gotta love the background noises. I don't know if you guys can hear all of this. Dogs barking, roosters crowing, cats fighting. It's never a dull moment around here. Okay. Next. Again, cosine, if I'm going to draw that triangle, I'll draw it over here so I have my space. Okay. This is x, y, and r. So cosine is x over r. Sine is y over r. And then if I multiply both sides by r, I have r squared equals -2x plus 2y. x squared plus y squared equals r squared, Pythagorean theorem. So I can replace this with x squared plus y squared. All right, now, who recognizes what this is? This is a circle. To put a circle in standard form, I know it's been a while since you've been there, I need x squared plus 2x plus, and I need to complete the square, so I'm going to move the 2x over, y squared plus minus 2y plus complete the square, and then whatever I add here and here, I have to also add to the other side. To complete the square, you take b divided by 2 and square it. So 2 divided by 2 is 1, squared is 1. Negative 2 divided by 2 is negative 1, squared is 1. So I'm adding 1 and 1 to both sides. So this is a perfect square and factors into x plus 1 squared. This is a perfect square and factors into y minus 1 squared equals 2. So this is a circle. I know it's been a long time since we've done this. The center would be at negative 1, 1, and your radius would be the square root of 2. If you need to go back and look at circles to remember all this, the H, K, and R, and all that kind of stuff, you certainly can. You don't have to be able to find the center. You don't have to be able to find the radius, but I'm just trying to jog your memory on where all of this is coming from. All right. Cosine of a sum. Now this one is on the cosine's already on the top. I don't have to change anything. So I have r equals 4, and I'm going to have cosine, cosine, sine, sine, sine. And I almost didn't leave myself enough room. Okay. Again, if you don't remember cosine of pi 6 or cosine of 30, sine of pi 6, sine of 30, draw yourself a triangle. Pi 6 is 30 degrees. This is 1, 2, square root of 3, which is the same as what we had on the other page, only this is in radians, not in degrees. Cosine of 30 is square root of 3 over 2. Sine of 30 is 1/2. I'm going to distribute that 4, and I'm also going to change cosine into x over r and change sine into y over r. So 4 times square root of 3 over 2 is 2 square roots of 3, and 4 times 1/2 is 2. Again, I'm going to multiply everything by r. I don't like the x after the square root because I don't want it to show that my x is inside there, so I write it out in front. It doesn't matter as long as your radical doesn't show it. But again, r squared is x squared plus y squared. And so we have another circle. So I'm going to take x squared minus, and I'll write 2 square roots of 3 this time, x plus, complete the square, y squared plus 2y, complete the square, and then I have to add those two numbers to the other side as well. So half of b, and if you need to, use your calculator, okay? So negative 2 square roots of 3 divided by 2, and then squared, and that's going to give you 3. A lot of people have difficulty with the radicals. The rules are the same. To complete the square, you take b divided by 2 squared. That's what goes here, and then of course we added 3 here, so I'm going to add 3 here. Half of 2 squared is 1, 1 squared is 1. And then when you factor, this factors into x minus half of this, okay, or the square root of this. You can think of it either way. Again, I know it's been a long time since we've done this. This factors into y plus 1 squared, and then we would have a 4 on the other side. So my center would be at square root of 3, negative 1, and my radius would be 2. 2 more. R equals 3, tangent secant. So going back to this same triangle, R equals 3, tangent is y over x. Secant is the reciprocal of cosine. Cosine is x over r, so secant's going to be r over x. So right now what I have is r equals 3yr over x squared. My r's are both on top, so I can divide both sides by r. I can multiply by x squared to get that out of the denominator. And then again, we don't have a circle. Circles are the unusual one where you have to put it in standard form. Everything else you're going to put in function form. Circles, of course, are not functions. So then I would divide by 3, and I'd have x squared over 3 equals y. On any of these on the homework, when you get stuck, send me a picture of what you've got so far, and I'll be like, yeah, looks good. You just missed blah, blah, blah. Or no, you erase, start over. This is what you need to do. And I can help guide you on some of these, okay? Especially if you get stuck on some of the circle ones. All right. Last one. Right away we have r squared. R squared is x squared plus y squared. Secant of 2 theta, okay? If you have your identity sheet, you have 3 possibilities for that secant of 2 theta. And all I can think of is one of them off the top of my head. It doesn't matter which one that you use, they're all going to be the same. You have cosine, so we're going to change this to 3 over the cosine of 2 theta. And here's a lesson in all of this. A lot of you memorized the sine and cosine sum formulas, okay? And you may not have memorized the double angle formulas. As long as you have the sine and cosine sum and difference formulas memorized, then you don't need to go through and you don't need to memorize the double angle formulas, okay? And so in this case, when you go through with the identities, you can just use the cosine of a sum, okay? So for example, and I'm using this in regard to calculus down the road, because it's only been a couple weeks since we've done the double angle formulas. But if you don't remember them and you do remember the sine and cosine sum and difference, you can create these, okay? So you can treat this like a cosine of theta plus theta, okay? And then if you have the cosine of a sum memorized, you'll realize that this is equal to cosine squared minus sine squared, okay? Because it's cosine, cosine, sine, sine, sine. So those are little tricks just down the road when it's been a while, and calculus is going to be a while, and your brain may not remember. And so if you did memorize at least the sum and difference ones, like we had talked about, it'll be easier down the road to do these as well. All right, back to this. X squared plus y squared equals 3 over, and now this is going to be cosine squared theta minus sine squared theta, okay? So cosine squared theta equals x squared over r squared. Oops, I forgot my 3 on top. And then sine squared is y squared over r squared. And actually, now that I'm doing this problem, so I'm going to multiply by r squared over r squared to clear those fractions. I have an r squared. And so even though this was an easy transition right here, I'm going to actually go back and leave this as an r squared because then it just divides out right away. So I have r squared equals 3r squared over x squared minus y squared. And then I can divide both sides by r squared, multiply by x squared minus y squared. And that is in standard form. And we're done. So, again, as you're doing these, if you get stuck, let me know. You can use your identity sheet. I don't expect you to have those memorized still. They don't come up often, but they do. If you need to draw pictures, draw yourself pictures if you can't remember some of these. But that's it for section 9.3.